Good evening to everybody. We are here to discuss about the transforming infrastructure management, how IoT CPS system are revolutionizing maintenance. First of all, before start, I welcome all the panelists on the dais, and I am going to start with a brief introduction. Uh, I was in the design of all the coaches. I'm keeping our discussion within the railway infrastructure and the rolling stocks because all the panelists are somehow directly or indirectly related with the working of the railways. I was in the design of LHB coaches when the technology was being transferred from LHB to India. It started almost in the end of 2000, around 99 or so. And we got the chair car coaches from the Linke Hoffman Bosch. Now it is Alstom. And they gave us the design of only chair cars. It was a ordinary and the executive chair car and one power car. And for us, the mandate was to transform that technology into making 2-tier, 3-tier, first AC, all type of coaches which are presently working in the country, and you all might be traveling in these coaches. And of course, now there are non-AC LHB also. When we were taking over the technology, so we were not getting guidance from the Germans as far as the making of new type of coaches was concerned. They were just giving us some basic ideas and they were saying just apply your mind. When we were applying the mind, because we wanted to take over the technology fully, and we were applying, and in that process we learned German also because all the drawings were in the German and we tried to convert them into the English. And in a few months we were able to do that also. And we started speaking some slangs of the German also after reading the drawing. In that process, the things were very good. And one day we were discussing with the bearing supplier because that taper roller bearing was introduced. That technology came from Germany and it was being given by Tata Timken and SKF at that time. And we were discussing and they said the chances of failure are 1 in million. After 1 million cycle, there can be possibility of the failures of the bearing. And when we calculated when the train will be running, because the train was supposed to be running at around 160, 180 kmph in the future. So we were thinking about 180 kmph running and we were calculating all the cycles. And we realized that if in a coach there are 16 bearings and 20 coaches are train and there are 320 bearings and 1 in million, if the hundreds of trains are running in the country, so how to avoid that situation of 1 into million? We wanted at that time of some sort of sensors which will give us some indication if this particular bearing is getting affected, it's going to come near to its 1 into million cycle. But nothing was coming up. We applied a lot of mind, we thought of a lot of designs. But at that time, I'm talking about 15 years back, 15, 20 years back. At that time, this technology was not there. Ultimately, we adopted the technology of German as it is without making much improvement because it was not available. But now, down the line when we are coming, now we have started discussing because now a lot of technologies are available to get that information. And a lot of trials are being done in Indian Railway at various locations to get that information and then to get that data so that the data can be utilized for doing the productive maintenance and to avoid the mishaps in working of the train. Now, at present, that thought has come into our domain in Indian Railway among the engineers, and we are looking for a system to collect the data from a moving train. I use the word moving train. The train can move from 100 kmph to 180 kmph, and to send that data to a central server, stationary central server, with a very low cost and with the flexibility to change the algorithm, to change the design, so that whatever my, in fact, the railwaymans are very demanding. They start keep on asking after few days, I want this change also. And if I don't give them change, they stop using my earlier model. So I have to be flexible with him and keep giving him change, keep meeting their demand. And they, of course, they demand from me with the expectation will improve upon in the future. So the challenge for Indian Railway, the question is, again I repeat, to collect the data from a moving train and send it to central server with low cost and flexibility in the design. So I request my all panelists to throw a light, to have a discussion, so that we enlighten and start using some ideas from the panelists in our railway system. Thank you. We can start with
Hello.
Mr. Atwood.
Dear friends, good evening. Railway system का backbone या foundation. Obviously, it's track, and fortunately, I'm the creator and maintainer of track for the last almost 30 years, since my joining in 93. As we all know, the total length, the route kilometer of Indian Railway are nearly 70,000, and stations are also nearly 7,000, which gives an average block section of 10 kilometer. Out of this 70,000 kilometers, nearly 2 kilometers track per station, that is nearly 20% of the total track is covered under track circuited, or this is covered or secured. What about the balance 80%? इस balance 80% में nearly 1.35 lakhs bridges are there, out of which nearly 12,000 are major and important bridges. These are not protected. The 80% of the track, which comes nearly 55,000 kilometer, and these important major bridges, 12,000. ये किसके भरोसे हैं? Just एक कीमैन, एक पेट्रोलमैन, जिसकी फ्रीक्वेंसी is hardly once in 24 hours. What about 23 घंटे और 55 मिनट? ये सारे जो लोकेशंस हैं, रिमोट लोकेशंस हैं, जिसके आज हम लोग काफ़ी बड़ी बड़ी बातें सब कर रहे हैं, सुन रहे हैं, और आप सारे एक्सपर्ट्स यहाँ पर हैं. अब मैं चूँकि ग्रास रूट लेवल का ट्रैक मेंटेनेंस और क्रिएशन से जुड़ा रहा हूँ, और ये 30 साल पहले भी मुझे इस बात की फिक्र होती थी, और आज भी इसी बात की चिंता है कि इतना एडवांसमेंट होने के बाद भी वो 80% ट्रैक हम लोग आज तक प्रोटेक्ट नहीं कर पाए हैं. जहाँ तक जो the same system which we are using in the station limits, that the same can be extended to the 80% balance track, but the cost is too much high. मेरे ख्याल से अगर 2 से 3 करोड़ पर किलोमीटर अगर आप करते हैं, तो it will go in lakhs of crores of rupees. इसी ट्रैक में जो पहले जो वीकेस्ट पॉइंट्स हैं, अगर आप देखें तो 2000 अवर जॉइंट्स, इनिशियली जो 13 मीटर में एक एक जॉइंट होता था, फिश प्लेटेड जॉइंट, 150 joints per kilometer with the weak links. Finally, we have started rolling the rail panels of 65 meter. That way, we have reduced our joints or the weakest links by 20%, 1/5. But still, we are having nearly 30 joints, weak links in the track per kilometer. Just imagine. इनके लिए जो भी प्रिवेंटिव हम लोगों ने मेजर्स लिए हुए हैं, प्रिकॉशनरी मेजर्स हैं, बट अगर वो टूट जाता है, हमारा जो भी सिग्नलिंग सिस्टम है वो दैट इज वी आर वर्किंग ऑन फील्ड सेफ सिस्टम, और ट्रैक में अगर कुछ फेल होता तो दैट लीड्स टू फेल अनसेफ सिस्टम. जस्ट इट इज कंट्राडिक्टरी. उस जॉइंट के टूटने के बाद आगे क्या होगा नोबडी नोज. आपका डे टाइम में कीमैन अगर उसने एक जो बीट होती है उसकी उसने इंस्पेक्शन कर लिया, रात में हो सकता है एक प्रोटेक्शन जो हमारे पेट्रोल मैन है वो भी अगर वहां से निकल गया, इसके जाने के बाद ही किसी फर्स्ट ट्रेन में अगर कोई फ्रैक्चर होता है वेल्ड में, रेल में, इसके बाद होल नाइट उसके ऊपर से ट्रेन जाएंगी. उसको डिटेक्ट करने का एकमात्र सिस्टम है जो पता लगेगा उसका डैमेज इतना ज़्यादा हो जाएगा कि रेल के बाद वो स्लीपर डैमेज होगा, इसके बाद आपका अंडुलेशंस क्रिएट होंगे, और फिर शायद लर्च किसी ड्राइवर ने अगर डिटेक्ट कर लिया तो वो टाइमली नेक्स्ट स्टेशन को बता सकता है. अगर वो नहीं बता पाया तो आप ये देखें कि पूरे होल नाइट कितने ट्रेन वहाँ से निकलेंगे. और ये डर जो है मुझे आज तक है. मेरी जब पहली पोस्टिंग थी, ऑब्वियसली साउथ ईस्टर्न से मैं बिलोंग करता हूँ, मेरी पेरेंट रेलवे वो है, तो मैं अपने सेक्शन में जब ट्रैवल करता था, छुट्टी में जब जाना होता था मुझे, तो रात में मुझे नींद नहीं आती थी, बिकॉज मुझे पता था कहाँ कहाँ पर वीक लिंक्स हैं. जब बहुत ज़्यादा समय इस तरीके से निकल गया तो फिर मेरे साथ मेरी फैमिली होती थी, वो कहते थे कि आप मतलब काफ़ी सिंसियरली काम करते हैं, और घर तक जाते जाते आप जैसे कम से कम 15 से 20 ऑफिसर्स के सेक्शन निकलेंगे, तो आप कहाँ कहाँ पर डरेंगे. आप अपने सेक्शन में डर रहे हैं जहाँ कि आपको एक एक इंच पता है. तो मेरा आप लोगों से मतलब मेरा कंसर्न ये है कि यहाँ पर हमारे एक्सपर्ट्स भी हैं हर तरह, हर फील्ड से. इस 80% के लिए मुझे नहीं लगता अभी तक कोई बहुत सीरियस एफर्ट्स या कंसर्न किसी ने लिए हैं. अगर इस 80% में मैं अगर जो ब्रिजेज की बात करूं, 12,000 ब्रिजेज हैं, एटलीस्ट हम एक प्रोटेक्शन सिस्टम उन ब्रिजेज में तो लगा दें. वहाँ पर फिश प्लेटेड जॉइंट्स हैं, कुछ पे LWR कंटिन्यू करते हैं जहाँ पर जो हमारे कोड्स मैनुअल्स परमिट करते हैं, ताकि एक अलार्मिंग सिस्टम वहाँ से पता लग जाएगा अगर कोई डैमेज है अप्रोचेज में और ब्रिज में, तो मुझे नियरेस्ट स्टेशन या कंट्रोल, ताकि मैं टाइमली एक प्रोटेक्शन ले सकें उसका. So this is my concern and this is my request to everybody. Thank you.
Good evening, guests and industry colleagues. I think what Mr. Rajput was telling that he was clearly defining the problem statements, that what are the challenges in terms of cost or operations railway is going through or railway has gone through earlier. And what sir was saying that 15 years back, these thoughts were there, but still, where are we today? We know. So somewhere the Internet of Thoughts need to move towards Internet of Things. That's why I define IoT. Coming on the challenges regarding the fractures or fish plates and all, I think most of the degradations happen over a period of time. Apart from some malicious attempt to sabotage something, that's a unique outlier. But in most of the cases, all the
the degradation regarding the fracture or the sagging or the ballast moving, all these happen over a period of time. And that is what IoT tries to address. Yes, business case is a challenge, but first of all, we have to see the solution, whether technology solution exists or not. The sensors allows you to capture the degradation in a period of time so that you can define certain thresholds beyond which you have to act instead of waiting for the accidents or mishaps to happen. So that is what the aim is towards sensorizing the track system and the rolling stocks. That how do we measure those things? Some of the trials which are being done currently or which are under discussion right now is that how do we capture those acoustics? So how do you capture the acoustics which are generated when the train is passing through various joints and all? Yes, I know the problem is humongous in terms of number of joints or tracks. But let's focus for the time being, let's focus on the technology piece first. And how do we capture the acoustics? Acoustics changes over a period of time when the deformation started happening. So the data learning, uh, which can be done, that acoustic has to be defined in a certain fashion through simulation of fractures, that yes, at this point the fracture will happen. All these things which are combining the sensors, the network, as well as AI/ML techniques to raise an alert are there as a silos today. But we have to think of again integration of all these things so that we can come out with a solution. There are some trials which are happening, but these trials are typically very silo oriented, and the comprehensive approach to deal with the situations or deal with the issues has to come now. In many of the cases, yes, I heard the centralization approach, but I have slightly different opinion that I think edge computing will play a pivotal role in dealing with real-time issues, because at many times the KPIs reaching from the site to the data center, computing, and then triggering back the actions may take some time. So edge computing is the answer for such cases. So hybrid computation at the edges as well as at the data center will be a solution for the use cases. Some of the low-lying cases, for example, it is being under discussion right now, is that can we have camera in locos? This discussion is happening currently. And then the idea was that how do we capture the images, what images need to be captured, what is to be captured, and how do we upload into the centralized system. But the idea is more on the black box oriented, that once something happens, then you will do some actions. You will take some, you will put out some data, pull out some data from the retrieval, and then make decisions, make observations that what happened during that time. But facial behavior is a known thing now from the cameras, video cameras, which can throw the light in terms of triggers, that whether some unauthorized person is traveling the loco, whether the driver is drinking, whether he is feeling drowsy. So there are a lot of cases which can be captured, and those things can be captured through computation at the edges in the loco itself, so that the triggers can be raised instead of uh, storing all the data and waiting for the next station to upload the videos, taking it to data center, and then computing it and then triggering the action. So the time is lost. So that's why I was saying that some of the cases you will have edge computing which will be required for agility to act faster. Few trials are being done by us also in 2 cases. One case is where we signed a MOU with NFR because in those areas the group of elephant or gang of elephants create ruckus on the tracks. So there are systems, and the trial is currently going on wherein the movement of the elephants create the noise, and through optical fiber we are firing the lasers, special lasers, which can capture this and send the signals. So initially it was only on the track, and then we thought that we may lose time because by the time the elephant groups or gangs reaches the track, it will be too fast to respond to the situation. So the area was demarcated that these are the areas, jungle areas from where elephants pass through. And the fiber was laid in the loop to cover up the jungle, inside the jungle, 1 kilometer, 0.5 kilometer, depending on the situation, so that early alerts can come. Similarly, in SCR also, there is a trial which is happening to capture a lot of KPIs in terms of KPIs like AC voltage, DC voltage, currents from signaling gears. And then those can be recorded at the central place. And any deterioration, whether it's overshooting or it's undershooting, those can be captured and actions can be taken. Yes, I agree that the approach is very silo in nature and everybody is trying to do something. But the business case will always be challenged. And here the Make in India has to come up to rescue from the high cost IoT devices so that the quantum of the problems or the quantum of the KPIs or number of devices is under control in terms of financial cost. But on the other side, if you see that the cost of infrastructure and the cost of life, which cannot be definitely quantified, that's also a big thing. And IoT will be nothing but a kind of life insurance. Most of us take life insurance, but how many people are able to claim it? So some of the percentage of the infrastructure cost can go, it should also be considered infrastructure, in fact, I will say that. Instead of seeing that it's a observation or it's a monitoring devices, if we term it starting that it's a infrastructure cost which has to be built into all the projects to capture the KPIs and to see the impact, that will make the difference. Thank you very much.
Thank you, Mr. Manoj. Now I request Mr. Sati. He has a lot of interest in IT, and he has developed this hobby. Though he's not presently, his profile is working is not for the IT, but as a interest, he has developed that hobby and he has gained a lot of knowledge in the IT. And he's going to give us a small presentation about his insights.
A very good evening. I shall be presenting leveraging IoT and digitization for enhanced productivity of railway infrastructure and customer experience. Next. So every business organization faces different types of challenges and problems. But sometimes the relation between the underlying reasons and the problem is quite strange. For example, in an automobile company, one customer came and he told that when he buys vanilla ice cream, his car doesn't start. But when he goes to buy either chocolate or strawberry flavor, his car starts normally. So initially it looked quite funny. They sent one person and it was found it is correct. Car didn't start when he bought vanilla ice cream. Then they went and found out, it was found out that the time taken to deliver vanilla ice cream was slightly higher as compared to other flavors. And the vehicle was parked in such a position that vapor block developed in the fuel line. And that was the reason why that car was not starting. Similarly, sometimes the definition of problem opens newer avenues for the solution. For example, Elon Musk, he defines darkness as absence of photons. So when this problem is defined like this, there are different solutions come to the fore. Now, the problem is for the railway is how to increase the utilization of railway infrastructure for train operations. Now, running more trains means more business. So there are two methods. Either you increase your train speed or you increase utilization of your tracks. Now, increasing train speed is function of rolling stock, that is coaches and wagons. So there is some limit to that. But there is huge potential for increasing utilization of railway tracks. And this can be done by using and leveraging IoT. How it can be done and why there is less utilization of railway tracks. Now here, most of railway is working on fixed block system. In case of fixed block system, it's not working here, sorry. The following train has to wait till the leading train clears the block 1. So there is a lot of waiting time for the trains. And this is the reason why there is less utilization of tracks. Now there are different methods of increasing utilization of railway tracks. But the best method is moving block system. In case of moving block system, the gap between two trains can be made minimum. And this block, actually I should need to clarify perhaps block, because those who are not from railways, block is a section of railway track where a train is authorized to move. So until unless the leading train crosses one block earlier than the following train, that following train has to wait. So in case of moving block, what happens, you can send train as near to the leading train. Following train can be as near to the following train. And this block, this gap, actually there are safety margins. So what happens if speed is more, braking distance is more. So you need to keep more distance, safety margin. So otherwise it will get, there can be accident. Now, if your train speed is less, in that case, you can keep less safety margin. So this is dynamic. So this all is possible in moving block system. Now, so the technology used for moving block system is called CBTC, that is communication based train control. Now in communication based train control, there is a CBTC or ATS equipment that interacts with the various equipments and railway stations, various there are signaling equipments placed along the track, as well as railway stations, and they also interact with the equipments placed on railway locomotive. Now, you might have heard about Kavach system. Now, Kavach is part of CBTC, and it is called automated train protection system. Now, when we are implementing Kavach, there is no direct economic gain, because it's just a preventive, it's just a protection system. But when we are going for the moving block system or CBTC, there can be economic gain. We can get more business, more traffic, and more earnings. Now, this is a brief schematic of Kavach, in which there is one antenna on locomotive, which gets its GPS location from the satellite. There is one radio antenna which communicates with the tower, which is located at railway station, and that tower communicates and provides information about that signal aspect from the station master's cabin. Similarly, locomotive sends its GPS location. Now this everything is done. Now why CBTC is not being implemented? The problem is exorbitant cost of implementation. So, but the same challenge can be addressed by using IoT devices. So this is actually a brief part of CBTC. CBTC includes ATS, that is automated train supervision, then ATO, that is automatic train operations, and ATP, that is Kavach, that is automatic train production. Now, when these Kavach equipments, when they are interacting, like equipment placed at loco, when it interacts with the equipments placed at railway stations, it has to be very secure. So for that, this is actually encryption method being used. And in this encryption method, there is a lot of exchange of authentication keys as well as OTP, that is SMS. So how IoT devices can be used as an enabler for deployment of CBTC? The first is they can provide feedback regarding occupancy of train on the track. Second is it can be used as secondary check for ensuring complete train passage. So devices can be placed on track for counting the axle, and accordingly that signal can be sent to the equipments. Then it can be used for monitoring speed of train. It can be used for raising alarm if train operates in unsafe condition based on given parameters like train speed, signal aspects, speed restrictions, and other parameters. Then IoT nodes can be used for monitoring and control of train operations inside tunnels and zones of and dark zones of radio signal. In Kavach system, the radio communication is not possible inside the tunnels. So these IoT devices, they can be used to control trains inside the tunnel and get signal out from them. Then other is IoT nodes can consolidate data of train operation for transmission to remote control unit for data logging, monitoring, extra. So actually, we can think of virtual block in which there are various IoT devices. They can operate and they can give the final output, whether train has passed, it is occupied, and other track parameter, and that can be consolidated. Data can be sent over the radio packet. Then other very interesting use of IoT is in areas where flooding occurs, which are prone for waterlogging. So IoT devices can be placed in areas where waterlogging occurs. They will be there until waterlogging occurs. As soon as waterlogging occurs, it will send alarm signal, and accordingly remedial action can be taken. Other is use of IoT is effective preventive maintenance and failure analysis by use of IoT. IoT devices can be used to keep log of any abnormal parameter, abnormal sound, jerk, extra, and audio and video record along with 11 data can be logged for further analysis and preventive action. So this event occurs during train operations. So that can be either sent over the radio to the server, or they can be recorded in memory cards. Then various types of alarms can be raised and logged for initiating immediate action, just like high axial temperature, vibration, and other parameters. They can be this is the alarm. They are extreme conditions. Other is various types of events can be logged for better understanding of functioning of various types of equipments. Now, for example, traction motor or other equipments, there are various extreme parameters. They work or they encounter extreme conditions like very high temperature, high load, high current, like that. So these conditions, they can be recorded and can be used for design improvements or increasing reliability of equipments. Other is data collected through IoT system can be used for predicting possible failures. Actually, telco company, they are using various devices for monitoring the vibration level, temperature, and other parameters, and they are feeding into the artificial intelligence system, and they are predicting what should be the corresponding temperature and vibration for that for those parameters. And if these vibration parameters are above the predicted one, they are predicting that the axle or bearing is going to fail. Other is enhancing the customer experience by leveraging IoT and digital control. So air conditioning is basically function of humidity and temperature. So at present, air conditioning is being done only based on the temperature. So using IoT devices, we can control temperature based on the humidity level. And this humidity level is actually available based on the comfort chart. And comfort chart divides. So that way we can provide more comfort to the passengers. Other is we can provide various value-added services to the passengers using data published by IoT devices. For example, alarm, wake-up calls at destination, then providing information of next station, train speed, train start signal, so that one who has alighted train doesn't miss the train. Weather extra. We can, based on the location of train, we can provide information regarding food, hotel, platform, next railway station, tourist places, history extra. Then and one of the most problematic area is the cleanness of toilets. So that can be addressed by placing a simple switch in washrooms, and as soon as a passenger switches on, signal can be sent to the concerned sanitation staff, and that person can attend. At the same time, we can also monitor how much time is being taken to attend. So these are just tips, and IoT is a new system. There is huge potential for increasing passenger comfort and providing value-added service to passengers. So I'll conclude that IoT is a revolutionary approach for future technology enhancement. Internet of Things is a new paradigm that has changed the traditional way of working into smart way of working. IoT can be used for better and effective maintenance of railway assets. IoT can be effectively used as enabler for implementation of CBTC and for enhancing customer experiences. Thank you.
Thank you, Mr. Sathi. It was a good presentation. Before we come to an end to a session, I just wanted to conclude whatever has been discussed among the panelists. Is the first point which was raised is regarding track maintenance. There is a need to draw attention to the 80% of track maintenance which has a weak joints and which are being maintained presently manually. So a lot of thought and lot of attention needs to be given to digitize the data through the sensors or whatever the way we come out and get the parameters of the track in the control room so that corrective action can be taken timely to avoid the mishappenings. This other thing which one of the panelists has said, acoustic capturing can be one way to monitor the performance of tracks, and there is a thought of using edge computing on the rolling stock so that the information can be processed on the rolling stock itself and the desired results can be transmitted to the center server so that the load of transferring data to the center server is reduced. And he has proposed for hybrid computing also, maybe some local calculations computing and then some central server computing. It's a mix, and it's a great idea that in some local area where some threat of the wild animals, elephants, or some other natural calamities there, local solutions have been found by laying the optical fiber network and capturing the data from there to alert the drivers or the train operators to avoid the mishappenings. In fact, in NF area, these happenings are very common, and most of the DRMs have a nightmare to control all these happenings. Though he has agreed that presently, whatever the approach of using IT is being followed is being done in silos. It's being done in titbits and at the various places. But I can only assure you, in railway, there is a lot of dynamism. The officers managing the railway are moving from north to south, and whatever information is available at one place, it will definitely move to the other place very quickly. And somehow they will be integrated together, and a common solution will be found from the centralized place, that is CRIS. I'm sure if the lot of experiments are being done, ultimately these experiments are likely to come in the CRIS to give them a centralized solution. And one of our panelists has showed a concern about the utilization of track. He has given the idea of using moving block system, of increasing the utilization of track. Of course, utilization of track is a serious concern. It's a very costly assets, and the addition of trains in the system is restricted because of non-availability of the track. Because most of the trains are running in the night, and because all the passenger wants to travel overnight from one place to another place, and the tracks are the most busiest thing in the night. So if some thought is given and moving block type of system is adopted, of course the utilization will be improved, and more number of trains can be introduced into the system. And he has proposed that using the IoT for capturing the various parameters of all the components of the rolling stocks. And he also proposed to use IoT for passenger amenities like air conditions, toilet, passenger information system. And the last but not the least, he said IoT can change our working to smart way of working. It was all the panelists have given a very good thoughts, and I'm sure the available persons will take it further for implementing it into our railway system. I'll invite any questions to the panelists from the audience.